Okay, we'll go ahead and start. This lecture is your last lecture before your midterm. So this will wrap up the content that I expect you to know for your midterm. This lecture is on fish and fisheries. So your readings that were due today, chapters 6 and 7, were all really related to the start of fisheries in the Gulf of Mexico. Some of the major fisheries, the things that brought people to the Gulf Coast for commercial harvest and for tourism. And so we're going to follow up on those concepts today and talk about how fish are related to their environment and why some aspects of the environment are more important for fish than others. And we'll talk a little bit about a couple of major fisheries that didn't get so much attention in those chapters that you read. I also wanted to let you know that all of the exam questions for you to study on, those are all in the exam review folder on Moodle. I've posted them as a Word document and as a PDF. So that way you can go ahead and work through those as you study. So today we're going to cover essential fish habitat, nursery habitat, marine protected areas, Gulf fisheries. We'll talk about two specific fisheries, red snapper and Atlantic cod. And we'll talk about federal protections for fish habitat. The learning goals for today are essential fish habitat includes any areas that are necessary for fish reproduction, growth, feeding, and shelter. Nursery habitats provide elevated survival and growth to organisms associated with them and are crucial early life stage component for many fishes. By protecting essential fish habitat, a marine protected area can improve fishing in adjacent areas where fishing is allowed. We'll learn that red snapper and Atlantic cod offer two vastly different perspectives on fishery management. And we'll learn about the federal protections for essential fish habitat that are offered by the United States. So before I start, I know I do have some people who enjoy fishing in this class. And I wanted to know, when you choose where to cast your line, what do you look for? You can just put it in the comment box if you want, or you can unmute yourself. What kind of features do you look for? So you're looking for some aspects of the current, some structured habitat, some three-dimensional features like ledges, grass laydowns or rick beds. I'm assuming those are both types of structure. A point on the bank, so areas where the current is changing and you might have some different variety of different flow rates for fish that are hiding amongst those areas. Yeah, seagulls as an indication that there's something around. Oyster reef as a structured habitat. Rock beds. Yes, rock beds. That makes sense. Yeah, so these are all talking about looking at specific areas that have some unique current structure, but especially looking at areas that have three-dimensional structure. So you cast your line in areas that have a lot of three-dimensional structure because you can pretty much assume that fish are hiding amongst that structure. And so essentially, that is essential fish habitat. You're identifying that as your fishing. So we're gonna go into more detail about why fish really, why they use these types of habitats, and overall how these types of habitats can be protected. So essential fish habitat, the definition, and this is also the federal definition for protection, as we'll see later, but the definition we're using for this class as well is it includes any areas that are necessary for fish reproduction, growth, feeding, and shelter. So ultimately areas where if they were absent, marine fish would not be able to survive. It includes many coastal habitats, as you might expect, including coral reefs, kelp forests, bays, wetlands, rivers, and all of the different estuarine habitats that we've been talking about. One of the aspects of essential fish habitat is that it has to be vital habitat for reproduction. Many fish or fish species come back to specific locations or habitat season after season to reproduce. They have very specific areas where they'll do this. So they do this because they need to use these areas as spawning grounds. They'll use these areas for egg laying and for protection, or as pupping or calving grounds. Pupping is usually a word that we use for instance, shark birth, which is usually not laying eggs. It's actually live birth. And then calving is a term that we use for live birth by whales. So if you hear those terms, those have pretty specific connotations. So why would fish come to one place for this purpose? Well, first of all, there's safety in numbers. So if you have a bunch of young being born at the same time, you can pretty much ensure that some of them are going to make it. So you're kind of overwhelming the system with new young fish, and some of them are going to get through. There's also safety in numbers for the adults. So if you have a bunch of adults together, you can ward off some more predators than you would if you were alone. Also, you might come to one location that's ideal for some reason to set the young up for success. So you might want to make sure that they are hatched or birthed in an area where they're going to be able to live and grow and have enough food and have enough protection. So you're setting them up for success. And then finally, fish might come together because many fish are broadcast spawners. And so they release gametes like sperm and eggs into open water for external fertilization. So they have to be in the same area. They have to be in a big aggregation if they are going to be successful in reproducing. And many, many fish do this. And interestingly, I wanted to throw out this little piece of knowledge that a couple of years ago, it was discovered that manta ray pupping grounds were off the coast of Texas in the flower garden banks. And up until a couple of years ago, we had no idea where manta rays were born. So that was pretty exciting. So that's right here in the Gulf of Mexico, off the coast of Texas, in some deeper reef environments. So let's talk a little bit more about those spawning aggregations. So every year at the end of the summer, one great example of a spawning aggregation are the Goliath groupers. And so groups of 100 to 150 Goliath groupers, which are huge, huge fish, they occur at a handful of shipwreck sites off the east coast of Florida. And this is a really predictable gathering. They come together to release sperm and eggs, so they're doing this spawning aggregation behavior because they are broadcast spawners. Some Goliath groupers will travel over 100 miles to join these aggregations, so they're pulling in fish from a wide, wide area. This is a picture of one of these aggregations off the coast of Jupiter, Florida. As you might expect, for a species that is heavily fished, gatherings like this can make them really vulnerable to harvesting. So if you wanted to, you could catch essentially every adult fish within 100 miles just by scooping up one of these spawning aggregations. So that's kind of scary for these fish. And one of the main reasons why grouper are so heavily protected, because they do this spawning aggregation behavior and they're very vulnerable. Essential fish habitat also includes some highly productive ecosystems that have a wide variety of food resources in abundant supply. So essentially that's that feeding component of the definition of essential fish habitat. It can also include areas with seasonally available prey resources, so where prey are really abundant in a given season. And so organisms will use these habitat, especially for their juveniles, to grow. Warmer temperatures also means faster growth. In many cases, as long as the temperatures aren't too warm, higher temperatures will increase metabolism and allow a fish to be more active and to spend more time foraging and eating prey and growing. So that means that many species that choose where to give birth or where to lay their eggs will find locations that are relatively shallow, warm, and with good food availability. And from what we've learned, we know that means many coastal environments. And so coastal environments can be key vital habitat for feeding and growth for many species at some point in their life. As you guys were getting at when you were talking about where to cast your line, vital habitat often includes shelter. And so habitat with a lot of three-dimensional structure, like mangrove forests, can protect juvenile organisms and allow them to reach adulthood. So I love this picture because it shows a shark that's swimming right up next to the mangrove roots, and you would expect that if there were any fish in this area, they would be hiding in and amongst these mangrove roots to avoid being eaten. It's exactly what these three-dimensional habitats do for fish. Excellent habitat for shelter includes many of the coastal habitats we've talked about so far, including mangrove, salt marsh, seagrass, and oyster reef. And these are considered nursery habitats because they provide elevated survival and growth to the organisms that associate with them. And they are a crucial early life stage component for many fishes. So this is where the young fish are growing up, a safe place for them to grow up. Relatively safe. And that would be a nursery habitat. Okay, so we're going to do our quiz now. Okay, this question is, why do many fish species come back to specific locations to reproduce season after season? More than one answer may be correct. Please choose all of the correct answers. Okay, so of all of these answers, the only one that was not correct was A. So fish do not come together to avoid regions with high fishing pressure. Actually, coming together makes them more susceptible to fishing pressure. All the rest of these answers were correct, and if it was working correctly, I would have asked you to choose all of these. Because there's safety in numbers, because many fish are broadcast spawners, and because some habitats or regions are better suited to provide good conditions for the young. Nice job. All right, so talking about essential fish habitat, it becomes pretty clear that these areas are very, very important for fish. And if we want to have fish to support our fisheries, then we need to protect them. And so that brings up the concept of having an area of ocean or estuarine habitat that is protected in some way. And these are our marine protected areas. Marine protected areas are often abbreviated as an MPA. They're areas in the ocean that are set aside for long-term conservation goals. Often those conservation goals are for conservation of fisheries species. Most MPAs still allow some sort of harvesting, some sort of fishing or material harvesting within the zone. About 6.35% of the ocean is protected by MPAs, but just under 2% are covered exclusively by no-take MPAs where no fishing is allowed. So really there's not very much of the ocean where no fishing is allowed. And there's honestly not much of the ocean that's protected by MPAs, right? So just over 6%, that's not very much. However, where MPAs do exist, they often cover, and I would hazard to guess that they all cover some sort of aspect of essential fish habitat. And by protecting the growth of fish inside the MPA, even if harvest is not allowed there, the goal is that the population should expand and spill out into adjacent areas where fishing is allowed. And so those fish that are doing really well in the MPA are growing big, they're having lots of young, and eventually those populations will spill out into areas where fishermen can take them. And so they should improve fishing, even if fishing isn't allowed in them. And in many cases, this actually does happen. So I want to spend a little bit of time talking about Gulf fisheries. In chapter 6 and 7 of Jack Davis's book, you got a lot of historical context for a couple of fisheries, especially mullet and tarpon. However, there are a lot of other really key commercial and recreational species in the Gulf, and here these two tables show you which are the major commercial species and recreational species. Overall, the shrimp fishery generates the most revenue from actual landed product in the Gulf of Mexico. And Louisiana is really, really important in terms of the oyster harvest. So Louisiana comprises almost 70% of the Gulf's total oyster harvest. So in terms of your own backyard, oysters are super important, as you probably know. Menhaden have the greatest landings weight in the Gulf of Mexico. They account for 78% of landings by weight. We'll talk about menhaden when we talk about estuarine productivity. They are a very important fish. Of all the fish that can be caught, spiny lobster will get you the most money per pound, just over $8. And menhaden is the cheapest fish, about 11 cents per pound. Of all the fish caught by recreational fishermen, spotted sea trout and red drum are the most frequently caught. Why do you think tarpon don't appear on this list? So we know tarpon are important. We're talking here about landings, about fish being sold. Why do you think tarpon don't appear? Any ideas? Overfished? No, not really. The tarpon fishery is actually pretty okay. They are a sport fish, yep. Too many small bones to eat, right, so they're not harvested for food. You would think that if it's a recreational sport fish, it would appear on the recreational species list. But because this species is not actually sold for food, in fact, in many cases, it's not technically landed on a boat, they're catch and release. In that sense, they're not managed like a recreational species. So it's a catch and release fishery generally. They're not harvested for food. Most of the fish that end up being caught end up surviving to be caught again. So they don't appear on this recreational species list because they're not being landed and sold. But they're still out there. They still support a fishery. Lots of people still come to the Gulf to fish them. But yeah, they're not landed like the rest of these. So I wanted to talk about red snapper because I've heard many scientists say that red snapper is arguably the only fish in the Gulf of Mexico because of how often we talk about it and its fishery and how much time we spend mulling over how we can make the fishery better. We do spend a lot of time talking about red snapper. It's a very important fish, so I should spend some time in this class talking about it. It lives in water about 9 to 60 meters deep, which is pretty deep. Sometimes it can be found even deeper than that. It has a relatively long lifespan. This is actually something that we found out relatively recently. We used to think it only lived like 10 to 15 years. Actually, generally it lives more than 50 years, in some cases up to 100 years. So they're old fish. They are fairly bottom dwelling, so they stay relatively close to the bottom. They form large schools around rocky bottoms, ledges, ridges, artificial reefs, oil rigs, and shipwrecks. So these are locations that you would go to fish for red snapper. Small juvenile red snapper will also use all sorts of coastal habitats that we've talked about as nursery habitat, like for instance seagrass beds and especially oyster reefs. And they're beautiful fish. And tasty, very tasty. fishing over the last 150 years, just as is the case for most fish species, it's depleted populations. And so that's led us to take a bunch of management actions that have led to rebuilding the population. So this would be controlling the amount of red snapper that can be taken, restricting the season it can be taken, or having size limits, having closures in some cases. And as the population recovers, which it is recovering, there are more and larger fish out there. But unfortunately, to date, the targets for eggs produced are not being met quite yet. It's coming, but those larger fish are not quite producing enough young for us to say the population has rebounded and to release some of those restrictions. And so that's led fishermen to be quite upset, as is understandable. If there are large fish out there, why can't some of these restrictions be relaxed? And so in 2016, Congress heard their complaints and decided to act on them. And instead of just opening up the fishery, they decided to collect a lot more information. So that way we can get a really good idea of what's going on with the snapper and have a lot of information to inform management decisions in the future, and also a lot of information that the fishermen can understand and digest and help to come to terms with some of the decisions that were being made. So Congress made $10 million available to get a good estimate of the population size. With red snapper, we don't collect them with nets. They're collected with hook and line. It's really difficult to know how many snapper are out there because we can't scoop them up with nets. They live around rocks and reefs. You wouldn't be able to pull a net there. They also live in deep water, and so you can't really send divers there. So if you need to count how many are there, you can't pull a net, can't send divers. It becomes kind of complicated. And so a bunch of scientists, a team of 21 leading fisheries experts, developed a program that is affectionately called the Great Red Snapper Count. It's not its official name, but that's what everybody calls it. And this is ongoing, so this is something that's been going on for the last couple of years. And the reports will probably start coming out of this soon. The Great Red Snapper Count, its goal is to count the red snapper in the Gulf of Mexico, to figure out how many are out there, what the sizes look like, so that way we can know if we're doing a really good job managing the species, if we're underestimating how many are out there, or if we're overestimating it. A suite of methods are being used, including direct visual counts using remotely operated vehicles. And these ROVs are unmanned, highly maneuverable underwater machines. This is a picture here of an ROV that's tethered to a boat. You can just kind of see the tether in the background. And this ROV is driving through a school of snapper and presumably counting and even taking lengths on those snappers so it knows how many are in that area. And there are faculty at LSU who are involved in the Great Red Snapper Count. I myself am not. I do research on red snapper, but I don't really do field research on them. So, but yeah, so LSU is definitely involved in this. So we will know more soon about how we should manage the red snapper fishery because there's been a lot of effort and money put into understanding what's going on with them. This is in marked contrast to the cod fishery and how the cod fishery ended up. And so next I want to talk to you about how things can go bad, essentially. The cod fishery is an example of a fishery that's poorly managed and entirely implodes. So in your reading, the Gulf of Mexico fisheries are often compared to cod. Your reading doesn't go over the end of the cod fishery, but we'll go over it in these slides. The cod fishery is an extremely old fishery. The British have been fishing cod since Roman times. Scandinavians have been fishing cod for over 1,000 years. You can see here the cod distribution. It's largely in the North Atlantic and the Arctic seas, so it makes sense that this is a British and Scandinavian favorite. By the mid-1500s, 60% of the fish sold in Europe was cod, and it played a major role in the British colonies as a major trade good. So you can see there are a lot of cod over here, of course in Canada and also in the northern part of the United States, like in Maine. And so these were important trade goods for the colonies to get things that they needed from Great Britain. The cod fishery was originally a hand line fishery. That means that you threw out a line with a hook on it and reeled them in by hand, which is quite a slow process. The catch was generally salted, and the boats were operated using oars and sails. And it was a particularly dangerous fishery because of the consequences of weather. This is all northern environments. I'm sure many of you have seen Deadliest Catch. Like, if you get into the Arctic Sea, things can get really unpredictable really fast. And so it was quite dangerous. And it was thought, even up until the late 1800s, that the following was true. Any tendency to overfishing will meet with its natural check in the diminution of the supply. And this check will always come into operation long before anything like permanent exhaustion has occurred. And so what they're saying is, as fisheries decrease, as we're catching more and more, eventually there won't be enough fish left to support the fishery. That's going to occur a long time before there's any harm to the fishery. And that may have been true in a time when we were catching fish using hand lines and oars and sails in a very dangerous fishery. But of course, there have been many technological advances that made the fishery more efficient and more safe. So steam power and canning happened in the mid-1800s. Canning provided an additional market for cod, and steam power, of course, lets vessels get safely to places quicker. Steam-powered vessels also are able to pull nets, and so eventually they were able to pull larger and larger nets. This image here is showing you a typical cod trawling setup. This setup is able to scoop up really any fish in the area. This is a lot more efficient than using a hand line. Freezing was introduced in the early 1900s, and that eventually led to the production of factory ships where these cod were able to be captured and flash frozen at sea. And so there was no need to go back to the dock and give the cod a rest as you were processing the product in canneries. You could just keep fishing as you were processing it. So you can see how this became a problem, and a lot more cod were being scooped up than ever before, with minimal effort and a lot more safety for the fishery. So as you might expect, the cod fishery started to collapse. It started showing decline in the early 1970s, and so you can see there's a little bit of a decline here up until the 60s, but then we became really efficient in catching cod, and so there was a big spike here in the 1960s, and then this decline in the early 1970s, that was because of the fishery collapsing. The response was that nations began to kick out all of the foreign ships. They're saying, these cod are ours. If they're not doing well, you're not allowed to fish here anymore. But at the same time, they were increasing their own domestic fishing effort. And so they were providing incentives like government subsidies to increase fishing for people from the homeland. And so in the US, we kicked out fishing fleets from Europe, but we added more fishermen from the US and from Canada. There was, after this action of kicking out the foreign ships, there was initial recovery. This lasted through the mid-1980s, and then there was another collapse. And in 1986, there were some scientists that were whistleblowers that suggested that the catch limits were and always have been too high. They said, according to their information, catch limits was twice as high as it should have been, which is pretty extreme. And they recommended reducing the catch limit by 50% to at least help the fishery along. It'd be limping along, but at least it would be limping. But unfortunately, the governments of Canada and the US ignored that warning. And several years later, in 1992, the fishery was suddenly and abruptly closed. There was a sudden loss of over 40,000 jobs in Canada, and this accounted for 12% of the workforce in Newfoundland and Labrador, in those regions. That's a huge amount of the workforce. So this would be very similar to what happened in areas of the US when the car industries collapsed during the recession, where, I'm from Michigan, so I definitely felt this pretty strongly, where a lot of my friends and family were out of the job because they were working in the auto industry. This would have been the same thing in Canada, but with the fishing industry. And it caused extreme economic hardship for many coastal communities. Many communities were entirely built around the cod fishery, so when it collapsed, they had essentially nothing. So obviously this is an example of a fishery that was managed poorly. This is an example where there wasn't enough time or effort to get the information that was needed to manage it, and people ignored the science in favor of pressing on and getting more money, more fish landed. So who's to blame? So first of all, efficient fishing gear had the ability to catch essentially every last fish, which is a huge problem. So we had a increase in effectiveness of fishing gear in grabbing fish out of the ocean. They were also targeting spawning aggregations, and so cod do spawn in aggregations. Here's an image of one off the north coast of Iceland in a kelp forest. These fish are coming together to reproduce. And so a trawler would come through and scoop up an entire group of spawning adults. There was, in the management, a lack of accounting for technological advances that increased fishing efficiency. They just kind of ignored that we had moved beyond hand lining and hook and line fisheries. Scientists had a poor ability to predict how many fish were out there. There wasn't enough effort or money spent trying to figure out how many fish there were. Government officials often raised catch limits or did not heed scientists' advice anyways. Even if scientists were giving advice, it was ignored for political gains. So this is a highly political fishery. And then finally, and as relates to our concept of essential fish habitat, the fishing method, so pulling a trawl along the bottom of a body of water, it destroyed key habitat for juvenile cod. And so juvenile cod were using the rocks and the vegetation that was at the bottom of that body of water to grow and, contribute to the fishery. And so by pulling those bottom trawls, they were actually destroying that nursery habitat. So not only were they grabbing up all the adults, they were also destroying the chance for any young to grow into adulthood. A double whammy. So as you might expect, it's really, really, really important to protect these essential fish habitats. We saw how it happened with the cod fishery. And so there's been a lot of effort in the past couple of decades to protect these habitats that will allow for persistence of these fisheries. We don't want any fisheries to collapse. It's horrible for the economy. And it's really hard to get them back once they're collapsed. So it's best just to be cautious. And so the U.S. now has federal protection for essential fish habitat. And this is in the Magnuson-Stevens Fishery Conservation and Management Act. It requires that all essential fish habitat, defined as we've defined it in this course, be identified and protected. It legally protects coastal waters against damage to essential fish habitat. And this includes direct or indirect physical, chemical, or biological alterations of waters or structures, and loss of or injury to prey species and their habitat. So it doesn't just include the fishery species that it's designed to protect, it also includes their environment and their prey. And it includes damages to any other ecosystem components if those modifications are negatively impacting the essential fish habitat. So there can be a lot of indirect impacts that are covered by essential fish habitat protection as well. When we're trying to determine what impacts there are to an environment, scientists can't just continually examine each component of the ecosystem to see if there's damage to those ecosystem components. So what we do instead is we try and look for a species or a few species or a few aspects of the environment that we can track instead that will give us a pretty good picture of what's going on. So we, for instance, can track the survival of an indicator species, which is a type of organism that signals the condition of the environment. And this often involves a lot of biological data that can be used to track the health of an ecosystem. So we can look at, for instance, the abundance or distribution of species that are sensitive to pollution or changes in climate or changes in structured habitat. We can look at the abundance of a sensitive life stage. So looking at the abundance, for instance, of juvenile blue crab or juvenile tarpon or juvenile cod. An example that we have looked at in past lectures is black mangroves as an indicator species for climate change. And so those black mangroves, they don't do well when there are really cold winters, and they tend to spread when the climate is heating up. So they can be a really good indicator of a changing climate. And that way you don't have to have climate sensors, temperature sensors everywhere to be able to tell that things are heating up. You can fly a plane over and say, well, the black mangroves are expanding, and so that means that conditions have been warming in this area. So I do have an assignment for you, and I want to just go ahead and go over what's going to happen in the next week before I launch you on this assignment for the last 10 minutes. And so next time on Friday, we have an optional exam study day. You do not have to come to class, but if you do, I will be fielding questions about all of those questions that I have assigned you to study for your exam. On Monday, February 15th, this is next week, Monday, is Mardi Gras. There's no class on that day. On Wednesday of next week, you have another optional exam study day, and then on Friday will be your midterm exam. So there's not going to be any lectures next week, just for studying. Will we have homework in this time period? No, you will not have homework in this time period from now until the exam. I won't be assigning any more reading. So pretty much just study for the exam for the next week. I've given you class time to do so. And yeah, you guys are going to do great. And I do encourage you to come to those classes just to listen in. You can study at the same time. Okay, so I do have one assignment for you guys for the last 10 minutes of class, exploring essential fish habitat. You're going to be looking at the website from NOAA that explains essential fish habitat, coming up with some limitations of the legislation that covers essential fish habitat, and finally looking at a mapping tool for a species of your choice to see where essential fish habitat is in the Gulf of Mexico. So go ahead and step through that assignment. It should not be a long one, but I at least want you to know where you can go to get more information on essential fish habitat, and I will see you on Friday for exam review if you don't have any questions for me. Alright, that's the end of class. If you did not quite get through this assignment, just go ahead and type something in the text boxes that you've missed so you can get the points for it, or you can continue working on it. It'll be open until noon if you don't have a class to go to right now. And I will see you all on Friday.